Hello, I'm Mrs. J, and welcome to my math class. The second part of the right triangle trigonometry is when you have two sides and you're looking for an angle, or you have a side and an angle and you're looking for another side. So these all involve having another angle other than your right angle. A trick you can use is called Sohcahtoa. It means sine is opposite over hypotenuse. Cosine, the A is adjacent over hypotenuse. And tangent is opposite over adjacent. And what that means is when you have your angle, opposite would be across from it. So this would be opposite. Adjacent means it touches it, and it's not the hypotenuse. And the hypotenuse, as always, is across from the right angle. So you have our hypotenuse. Opposite is opposite of the angle, and adjacent is touching the angle with the hypotenuse. The other thing that comes up on a lot of the problems with these is angle of depression and angle of elevation. Angle of depression goes down, it depresses. And angle of elevation, it goes up. So if we look at this horizontal, and it's always from the horizontal, the angle of elevation from where this guy's standing, his view, would go up. The angle of depression for his view would go down. Over here, we have a hot air balloon. If it says the angle of depression, then you're using this horizontal and going down. If it says from the tree at a distance, the angle of elevation, it would be here. Now when we have these two horizontal lines, notice they're parallel. When you have two parallel lines, this line that goes through is called the transversal, and opposite interior angles are equal. So these are the same. These two are not the same, but these two are opposite alternate interior angles. And so they are the same. Over here, if we had this one, and this one would be equal. Alternate interior. So it wouldn't be these two. This one, this angle would equal this one. So when you have two horizontals, the alternate interior angles are equal. So it's two horizontals cut by a transversal. So alternate interior angles are congruent. So let's try an example. A red cardinal and a yellow warbler are perched at the tops of two trees, as shown. The given angles of inclination between the apple and the bird, which is closer? Which is closer to the apple, and by how much? So first we need to find these. We could use R for red and Y for yellow. So if we just look at this triangle here, we're using this angle, and we have adjacent and hypotenuse. Adjacent and hypotenuse. Adjacent and hypotenuse means we're using cosine. So you want to think about the Sohcahtoa. For the red, you have this angle, and then this is adjacent and hypotenuse. So the sine, cosine, because we circled this one. The cosine of 31 degrees is equal to adjacent over hypotenuse. Adjacent is 10, hypotenuse is r. That's what we're looking for. Now to solve it, you can multiply the r to the other side to get rid of the fraction. So we have r cosine 31 equals 10, because the r's will cancel. And then we're still trying to get r by itself. We'll divide by the cosine of 31. And make sure your calculator, this is degrees, so make sure your calculator's in degrees. Mine's in degrees. And we want 10 divided by cosines here, 31. And it didn't say what to round to, so I'm just going to round to the 10th, 11.7. They didn't give any measurements. Oh, meters. So the red cardinal is 11.7 meters away. For the yellow one, again, we're thinking of Sohcahtoa. If we look here, we have an angle, we have opposite and hypotenuse. Well, opposite and hypotenuse, that's this one. So we're using the sine of 41 equals opposite over hypotenuse. Multiply the y to the other side. And divide by the sine of 41. And then plug it in your calculator. 9 sine 41. And we get 5.9. So the yellow warbler is closer to the apple by so many meters. Now we need to find that. To find it, we just subtract them. 11.7 minus 5.9. 5.8. So the warbler is 5.8 meters closer than the cardinal. Try another one. Two ladders are leaning against a building as shown. Answer the questions that follow. And so we have this. The first question says, what is the angle below the shorter side? So we're looking for this angle to start with. But sometimes finding the other parts might be needed before you can find something, because if we just use the small angle, we only have one piece of information, the 12. We need something else in this triangle to find this. Well, what if we get this height? Because notice this is a big triangle here. And in the big triangle, we have this length, the hypotenuse, and we have this angle. So we could find the height of the building. And notice how tall is the building is one of the questions. So we would find how tall the building is first, using the large triangle. We'll let the building be x. This is our angle. We have opposite and hypotenuse. Opposite and hypotenuse. This is the hypotenuse because it's across from opposite and hypotenuse, sine. So the sine of 34 equals opposite over hypotenuse, x over 18. Multiply the 18 to the other side. So 18 sine of 34. And 10.1. meters. So the building is 10.1 meters tall. Now we can find this one because we know this is 10.1 meters. So looking at this one, again we have opposite over hypotenuse. So the sine of this angle opposite over hypotenuse, 10.1 over 12. Now to get this by itself, we take what's called the inverse. So we have the sine inverse of 10.1 over 12. The inverse are up here, and we want the sine. So it's second and sine. Second and sine. And then you put your 10.1 divided by 12. It's 57.3. And it's an angle, so it would be degrees. Because my calculator is set for degrees. The last question says, how far apart are the two ladders on the ground? Well, that would be from here to here. How far apart are these ladders? Well, in order to find that, we can find the whole distance and this one and then subtract them. So if we find this whole part here, and then we subtract this one out, it will leave us this. So we'll find the whole part first. We'll use L for long. So we use this angle. We're using opposite and adjacent, which is tangent. Opposite and adjacent. We could use either one. Okay, so 34 tangent, opposite 10.1 over adjacent, which we're going to use L for long, the longer side, longer distance. Multiply the L to the other side. And divide by the tangent. Divided by tangent 34. 14.9, but that 7's going to round it up, so it's actually 15. Now we'll find the shorter side. Well, we know this angle now is 57.3. We're doing, again, tangent, opposite over adjacent. Or you can do adjacent and hypotenuse and use cosine. But since I have this written right above it, let's do another tangent. Opposite over adjacent. Tangent 30, oops, not 34th, this one's the other angle. It's the 57.3. So this angle, opposite over adjacent, 10.1 over the shorter side. Multiply the s to the other side. And divide by the tangent. And just plug that in. 10.1 divided by the tangent of 57.3. And we get 6.5. Meters. So this short distance is 6.5. So if you thought of this with our angles here, this whole distance is 15. This short distance is 6.5. So if we subtract these, it will tell us what this value is. And we get 8.5. So the distance between the ladders is 8.5 meters. And that's all for today.